All right. All right, so I just wanted to take a few minutes to talk about the kinds of things that we're doing in section 5.3. This is just an extension of the kinds of things that we were doing in the previous section where we were doing some of these basic trig identities and so on and trying to verify them. Instead, now we're actually going to be solving. Remember, solving means that you are actually coming up with a value of x or theta or whatever your variable is that makes the statement true. And the main thing to do here is to realize that all the kinds of tricks that you learned in classes like Algebra 1 and Algebra 2 are going to be just fine. It just takes a leap of faith to realize that you can use those with trig identities too, as long as you follow all the rules. But you're going to be doing the same kinds of things you do whenever you solve an equation, like collecting terms and factoring, getting whatever you can to isolate the trig function on one side of the equation. Because once you just have like sine of x equals something, well, then inverse sine will become your friend. It will be able to undo the effects of those. But we'll see some examples of that in just a little minute here. Let's work through example 1 on page 365. This example here just says solve this simple equation here, 2 sine x minus 1 equals 0. All right, make sure you understand the order of operators here. This is 2 times the sine of x, and then that whole thing minus 1 is equal to 0. So if we were going to attack that little problem here, we would take it like this, as it was given in the book. And I think we can all agree that the first step would be to move that negative 1 to the other side. Remember, what we're going to try to do is we're going to be trying to isolate the sine x on one side of the equation so that then we can just use inverse sine to solve the problem. All right, so I pulled that 1 over to the other side. I got 2 sine x equals 1. And then I can pull the 2 over to the other side, and I just have the sine of x equals a half, which starts looking like a solution. But remember, we need to find the value of x that makes this true. All right, well, this sounds like a tool for using the unit circle. Don't get me wrong, you could also use the inverse sine button on your calculator. You could have taken the inverse sine of both sides and gotten x equals the inverse sine of a half. Or we could use the unit circle and look for the two places on the unit circle where the sine, which is, remember, the second coordinate of those points on there, was equal to a half. And I see that there are two such places on here. It looks to me like x is equal to either pi over 6 or 5 pi over 6. Both of those places would work just fine on this equation. If you plugged in x was equal to pi over 6, the equation would work. If you plugged in x equals 5 pi over 6, the equation would work. Now, the book wants you eventually to start noticing a pattern to these answers here. I don't really have the right kind of markup tools to show you this on a YouTube video, but if we went all the way around the circle and then to pi over 6, we'd actually be at, what would that be, 13 pi over 6? That would work too. And so would another 2 pi beyond that, which would be, I think, 25 pi over 6 and so on. But for today, we're not going to do that. For today, we're only going to worry about the solutions in some range of some interval of possibilities, like from 0 to 2 pi or from 0 to pi. So for this answer, this would have been fine. We would have had two answers just came to us from the unit circle. What if you had done this with your calculator? Well, calculators aren't going to give you two answers. They're only going to give you one answer. So we would have had a little bit of a challenge there. For today, let's focus on ones we can do using the unit circle. All right. Now, if I keep moving forward here, there we go. We're going to be doing equation 2 next. Now, this particular tool that I'm using to make these recordings only lets me do 10 minutes at a shot. So let me, since we're probably getting fairly close to 10 minutes here, let me go ahead and stop this tool, and your substitute will move on to the next video.